now we continue with the topic polymerization. What is the definition of polymerization? What is a polymer? Just have a look. Polymer is a long molecule formed by joining together of the thousands of small units called monomer. So many monomers are joining together to form a chain-like molecule called polymer. Now each and every unit is called monomer, and repetition of the unit is making the polymer. Now the repetition can occur in different ways. Sometimes the monomer is only one type, single type of monomer present, that is called homopolymer. A polymer consisting of same type of monomer unit, that is called homopolymer. And two different monomer units combined together, it is called copolymer. Okay, so there is homopolymer, copolymer. Sometimes we have regular arrangement. Monomer B, again A, again B, that way repetition of the unit. That is a copolymer. It is called regular copolymer. Why? Because you are getting the alternate specific arrangement, A, B, or AA, BB. That also can be a regular copolymer. Sometimes you can have random, AA, then B, then AA, then BBB. So it's a random one. So that is called random copolymer. Sometimes we can have a number of monomer units clustered together, called a block. So block A, block B, block A, block B. That is called block polymer. Okay? So different types of such polymer. Now polymers we can classify as different, depending on their nature, we can classify. Like natural polymer, synthetic polymer, semi-synthetic polymer. Natural polymer example? Bolo? Natural polymer? Anyone can say? Natural polymer? একটা natural polymer নাম বলো। Protein. আচ্ছা, protein, cotton, cellulose. So these are natural polymers. Cellulose, starch, these are natural polymers. It is available in all foods. Starch is available in rice. It is there into potato. So this is also polymer, but these are called biopolymer. And sometimes these biopolymers are all natural. But all natural polymer we may not consider as a biopolymer. Achha, there is synthetic polymer and semi-synthetic. Synthetic polymer example, plastic, different plastics that we make. How do you make polymers? Any general idea that how do you make our synthetic polymers? What is the raw material? What is the source? Raw material care. Petroleum products. You get it from petroleum. Naphtha, for example. Have you heard naphtha? Naphtha is there is a Haldia petrochemical also. There is a naphtha cracker unit. Cracking means what? Breaking into small fragments. That is called cracking. Thermal cracking, catalytic cracking. Cracking means large molecule broken into small fragments. Now, naphtha cracker unit, breaking the naphtha into small fragments. That is called happening to naphtha cracker unit.
May I go back?
Okay. So naphtha cracker unit. So from that you are getting naphtha, different small fragments like propene, butene. These type of fragments are there, and they are getting combined, polymerized together to give you our synthetic polymers like polythene, polypropylene, butene, so polybutadiene. So this type of polymers you are getting synthetic. Some are called semi-synthetic. Semi-synthetic means you are originally taking natural and modifying it. Example, cellulose acetate is natural one. Cellulose is a natural one. We are making cellulose acetate, cellulose diacetate, cellulose triacetate. These are semi-synthetic because originally you are taking natural and we are doing some modification to that. You know, cellulose, cotton, these things are very common. Do you know rayon? Rayon is a modified polymer which is originally taken from nature, but after that is modified. That is called rayon. So this rayon is a semi-synthetic polymer. Okay? That means you are taking some natural source and then you are modifying. Natural source means for rayon, cellulose, cotton. So simply you take cotton, dissolve into NaOH, filter, a portion is soluble, a portion is not insoluble. Insoluble part you remove, Soluble part you again precipitate with the help of some acid. You get very fine type of cellulose. That is wrong. Now degree of polymerization, number of monomer units into chain. That is degree of polymerization. Number of monomer units into a chain, it is called degree of polymerization. Now, if you have, just imagine, if you have all the chain length, same size, same number of monomer unit, theoretically, if it is there, then what do you call it? You have all the chains, say degree of polymerization same, and all the chains are of equal length, size and mass. If length and size is same, mass must be the same. Length, size, mass, everything same. This is called monodisperse polymer. Monodisperse polymer. These small things you should write down because it may not be have into the PowerPoint there. Okay. So these things whenever I remember, I will dictate you and you write it down. Okay. So what is monodisperse polymer? That can be one marks question. Monodisperse polymer. What is that? All the fragment monomer unit. Polymer chain unit, not monomer. Polymer chain unit of equal mass, size and property mass. Okay, so if it is there, sometimes it may happen once you make the reaction condition in such a way, reaction condition are making such a way that all are getting in the same length. Okay, so in that case it's called monodisperse polymer. And how many different type of fragments you have, small, medium, large and also etc. Accordingly, there is an index there, it's called polydispersity index. Polydispersity index, PDI, very important term. Polydispersity index, PDI. What is polydispersity index? That is weight average molecular weight divided by number average molecular weight. MW bar divided by MN bar. That is called PDI, polydispersity index. I repeat again, polydispersity index, PDI, equal to MW bar by MN bar. MW bar means weight average molecular weight, MN bar means number average molecular weight. Number average molecular weight is MI summation of MI divided by summation of Ni. Okay, I think I should write it down, right? So PDI equal to PDI equal to MW bar by MM bar. Do you understand what is the meaning of this bar? Yes. MW bar by MN bar. Now what is MN bar and what is MW bar? That also you should write. MW bar equal to MI Ni summation of MI square Ni divided by summation of Ni, and MN bar summation of MI Ni divided by summation of okay. So this is the formula, general relationship between the MW bar and MI bar. And what is MI Ni? Let me clarify what is MI, what is Ni. I means it is a general term. Means how many number you have, that is I. Like Ni, you have how many number, that always varies now. So now it may happen that small unit you have 20 number. Okay, so that number is Ni. And what is the mass unit? Is 20 monomer unit. So it will have some molecular weight. So that molecular weight into its number. 20 number of such fragments. So 20 is what? As an example, that is the Ni into each fragment mass. That is Mi. So first one M1 N1. Now there will be M2 N2. That means Mi Ni equal to summation of Mi Ni means M1 N1 plus M2 N2 plus M3 N3 plus dot. Divided by N1, Ni means N1 plus N2 plus N3 plus dot. So that way also you can write. Okay, you can write that also with that. What I have written along with that, you can write this also. Then what is so m1 square n1 plus m2 square n2 plus dot 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 divided by n1 plus n2 plus n3 plus that also you can write. Could you understand, or once more I should clarify? So if you have different fragment chains, small, medium, large, very large, and etc. Like you have small, medium, large, short size na. So here also the fragment size we have small, medium, large, extra large, double XL, and so on. So here also you have something like that. So small fragment you have 10 in number. Then medium fragment you have 20 in number. Large one you have 30 in number. So this number is Ni, and this mass, each fragment has a separate mass, that value is Mi. Now if you have summation divided by total number, denominator is always total number, but the other one Mi at the denominator. Okay, so that way, both the way we are getting two different molecular average molecular. Why average required? Because chain length is not equal. For other things other than polymer, if you take some small molecule like PCl5, SOCl2 and etc. So what do you get? You just only have a single molecular weight, and this is very much specific. But for a polymer, it is not so specific because you have different size chains. Into the same polymer only, you have so many different size chains. So that's why always you have to have an average. That average you can calculate in two different ways. One is called number average, another one is called weight average. So now the number of average with respect to number is getting the importance, and weight average means mass we are getting squared. Okay, mass we are giving more importance. That's why mass is getting squared. But if you are making the mass squared, you must be divided by mass again to get it back. So that's why in the denominator also you have again mass factor. Mass square is there in the numerator, and the denominator you have mass. So that's why cancelled out. But it will not be, the value will not be the same. You are getting some different value, obviously. MW value and Mn value will not be the same. Now next classification, addition, polymerization, chain and condensation, that is called step. Chain polymerization happens with the help of some catalyst called Ziegler-Natta catalyst. Ziegler-Natta catalyst. That is Ti's titanium tetrachloride plus triethyl aluminium. These two combination is called Ziegler-Natta catalyst, Zn catalyst. Zn catalyst is a mixture of two things, titanium tetrachloride plus triethyl aluminium. You can write down Ziegler-Natta catalyst. Ziegler-Natta catalyst. Natta is NaTTA. Ziegler, Z-I-Z. Elia, Ziegler-Natta, NaTTA, catalyst. What is the compound? It is TiCl4 plus Et3Al. TiCl4, titanium tetrachloride plus triethyl aluminium. This mixture is called Ziegler-Natta catalyst. What is the purpose? It initiates the radical mechanism. This catalyst initiates the radical mechanism, and that's why we get the addition polymerization. Condensation polymerization or step polymerization, it happens by molecules, those who are getting joined together stepwise one after another. That is called step growth polymerization. So chain growth polymerization happens by random addition. Addition reaction is what? A plus B equal to C. That is called addition. Now ethylene plus ethylene, you are getting diethylene, then triethylene, tetraethylene, quadruple, penta, hexa, hepta, octa, nona, deca. One monomer you need, two monomer you need, 3, 4, 5, 6, 7 getting joined together by addition mechanism. So that addition mechanism happens by radical formation. Who will supply the radical? Ziegler-Natta catalyst, producing certain radical. So that radical mechanism takes place, and it always happens into non-polar solvent. It happens into non-polar solvent. Okay, that you must remember, that is into non-polar solvent. So non-polar solvent, radical mechanism, these two are always combining. Whenever non-polar mechanism, non-polar means radical mechanism. Radical means non-polar mechanism. There is a, you can consider it is a sort of combination effect. Combination. Always, whenever you talk about radical, means non-polar, and ionic means polar. And ionic polar means water, most of the cases, aqueous medium, because water promotes this sort of ionic mechanism. Water promotes this sort of ionic mechanism. That's why ionic reaction happens into aqueous medium. Okay, so and this step growth polymerization or condensation occurs into aqueous medium, and this chain growth polymerization occurs by radical mechanism in the non-polar medium. What type of non-polar medium? There can be ethylene chloride, methylene chloride, methyl chloride, methylene chloride, chloroform, carbon tetrachloride, or maybe benzene. Benzene is a good solvent. Hexane is a very good organic solvent. So in this type of solvent, this reaction will occur. But what is the main trouble of this type of solvent? These are all volatile, these are carcinogenic, these are toxic, bad for the environment. So negative side also you should know. Everything has some positive side and negative side. Positive side, the reaction occurs very nicely in this type of solvent. But negative side, the solvent, until unless you recover the solvent, recovery possible. If you recover the solvent, is better. Volatile means उड़े जाए. It will evaporate very easily. Like ether, it evaporates. Alcohol evaporates. So these are called volatile. So this volatile liquid you have to recover. If you can recover, it's good. Otherwise, it will create the pollution problem into environment. Okay. Now condensation, aqueous. But advantage of addition polymerization, it occurs very fast. You get your product very soon. Condensation polymerization problem, it takes very long time and your productivity is never 100%. Reversible reaction. Why reversible? Because water gets accumulated, it will give back reaction. Okay, water gets accumulated and it will always give backward reaction also. It will give you equilibrium, reversible equilibrium process. As a result, never 100% reactivity will achieve. कि समझा कि नहीं समझा? हिंदी में समझा है? देखो क्या है, नॉन पोलर सॉल्वेंट में जब आप रेडिकल मैकेनिज्म करेंगे उसका कुछ बेनिफिट होता है, कुछ नेगेटिव इफेक्ट भी है. देखो दोनों देख लो. पॉजिटिव इम्पैक्ट क्या है, तुमको प्रोडक्ट बहुत जल्दी मिल जाएगा, फटाफट हो जाएगा. इट विल टेक लेस टाइम. तो इट विल बी एडवांटेजेस फॉर द कंपनी. कंपनी में तुम कुछ रेडी पॉलीमर बना के बेच रहे हो, तो बेचना है तुमको, तो बनाना है तभी तो बेचोगे. तो जल्दी बनेगा तो तुम्हारा फायदा है ना, नहीं तो सब लोहा का लोग बैठ के गप्पा मारेगा, है कि नहीं. तो उसको बैच कंप्लीट होगा तो अभी तो काम पे लगेगा वो लोग. तो तैयारी हो चल रहा है तो सारा दिन भर अगर लग गया तो प्रॉब्लम. अच्छा, तो ये जल्दी होता है. दूसरा वाला स्लो होता है. आई एम कंपेयरिंग द बोथ. एडिशन में सॉल्वेंट है ऑर्गेनिक. ऑर्गेनिक सॉल्वेंट इज हाईली वोलेटाइल, जो उड़ जाता है, उब जाता है, हिंदी में बोलते हैं उब जाता है. तो प्रॉब्लम यह है, तो पॉल्यूशन क्रिएट करेगा और उब जाएगा तो पैसा भी तो उबेगा, क्योंकि वो तो खरीदना पड़ता है, फ्री थोड़ी है. सॉल्वेंट तो खरीदना पड़ता है, महंगा भी है. तो उसको उड़ने के लिए तुम छोड़ो ही मत, कलेक्ट करना है. अच्छा, ये हो गया उसका. और इसमें सॉल्वेंट है वाटर, दूसरे में सॉल्वेंट है वाटर, वो तो ऑलमोस्ट फ्री है. अच्छा, तीसरा एडवांटेज डिसएडवांटेज, ये इसमें तुम्हारा कैटलिस्ट चाहिए ऊपर वाला. एडिशन पॉलीमर में कैटलिस्ट चाहिए, जिगलर नाटा कैटलिस्ट, जैसे नाम मैंने बता दिया ऑलरेडी. लिख पाया क्या है कैटलिस्ट? जिगलर नाटा कैटलिस्ट का फॉर्मूला E3A + TiCl4. ठीक है, तो वो अप्लाई करना पड़ेगा, उसका भी कॉस्टिंग आता है. सब कुछ भी फ्री नहीं है दुनिया में, वो भी कॉस्टिंग आता है. और दूसरे में क्या है, एसिड बेस कैटलिस्ट होता है. एक्वस मीडियम में जो हो रहा है स्टेप, उसमें एसिड बेस कैटलाइज्ड होता है, तो चीप होता है कंपैरेटिवली. नाउ एडिशन एंड चेन और एडिशन और चेन पॉलीमराइजेशन. अभी तो जस्ट यू रीड योरसेल्फ, इट इज ऑलरेडी रिटन. Simple molecules are joining together, monomers are just joining together one after another. And why it is called chain growth? Because both the hands of the double bonded compound breaks open and joined with the other molecules, and that's why the chain length drastically enhanced. The chain length increased a lot, very fast. Whereas this this conditional polymerization happens in a stepwise. One by one molecules comes into effect, and this addition by molecular level is very slow. Why molecular movements are itself slow? Why molecules are slow? Why molecules are slow? Because they are bulky, big. Molecules are big and bulky, so they will take more time to move, more time to join. Reactions are slow, and backward means forward, backward. Again, it will make the whole thing slower. Some forward, some backward is happening, making things slower. And addition, no backward mechanism. Once polymer is formed, it will never give you the monomer back. Okay. So, addition polymer example: polythene, polypropylene, polystyrene, polybutadiene. Okay. Ethene to polythene. This is the way it is joining. One molecule, two molecule, three molecule, four molecule, just joining one after another, very, very fast rate. And polymer is always written like this, drawn like this. See, this is open-ended, this is open-ended. We cannot go on writing it again and again and again. We cannot repeatedly write it. So that's why we have to keep both the ends open to make people understand. Yes, it's a polymer, so it is not ended over here. That's why it is called open-ended molecule. Both sides are open. Condensation polymerization occurring by condensation reaction, obviously. And during condensation reaction, two monomer units join together and release of a small molecule always happens. Like HCl goes out, water goes out. Example: if you take adipic acid plus hexamethylene diamine, you get water along with nylon 6,6. Nylon 6 is the main product, along with you get some water molecule. Now, go on joining these molecules and you go on getting water molecules. Now, these water molecules also accumulated there. As a result, backward reaction may take place. Hydrolysis can take place. That is the backward reaction. First condensation followed by hydrolysis. That problem is there. But if you raise the temperature a bit, some of the water molecules will be evaporated out. So, in that case, the lack of water will make the reaction forward. Because product you are removing, one of the product you are removing, so obviously forward reaction will go ahead according to the Acetylia principle. If you one of the product can be removed, then always reaction will proceed in the forward direction. That will happen here. Okay. Now if you take, instead of adipic acid, if you take adipoyl chloride, COCl, instead of COOH you are taking COCl. That is called adipoyl chloride. In that case, instead of water you get HCl that is coming out. That HCl can be removed by adding some base. That's why it is a base catalyzed reaction. That type of steps can be taken. Example: polyester, nylon. Okay, polyester, nylon. Now, after so much of discussion, if I ask you, styrene butadiene rubber, is addition polymer or condensation polymer? That's a trial, whether they are understood or not. SBR, styrene butadiene rubber, is it addition polymer or condensation polymer? Styrene butadiene rubber, addition polymer or condensation polymer? Try out. If wrong, no problem. Bolo, bhul hote dao. SBR is what? Addition na condensation? তাহলে আর কি বুঝলে? Addition. Yes. কেন অ্যাডিশন মনে হলো? কেন মনে হলো বলো তো? Double bonded compound. Styrene as well as butadiene both are double bonded compound. Double bond breaks and join together. Obviously, it will give addition. So, addition polymerization. NBr, SBr, they are all addition polymerization. Natural rubber also addition polymer. They are not condensation polymer. But bakelite, condensation polymerization. Nylon 6,6 here. Nylon 6,6 here. So I think the picture has got a bit. This is more clear, na? The full screen was a bit clumsy. Now this is hexamethylene diamine and this is adipic acid. So what is going out? Along with formation of the polymer, H2 is going out. And what you are getting as the main product? Nylon 6,6. This is hexamethylene diamine and this is adipic acid. Both are having 6 number of carbon atom in the unit. Here carbon atom 6, here also carbon atom 6. 4 CH2 and 2 COOH group, so that means total 6. So that's why it is called 6,6. It is written in nylon, sometimes it is written 6,6, sometimes 6,6, sometimes 6:6. Doesn't matter. It represents the same thing. We chemists are not that much rigid in these things. Okay. Okay, you can write 6,6, you can give 6:6 and write that. Or 66 itself. We will understand what you want to say. 66 means not 66 here. We understand that. Okay. Next, copolymerization. Already told you that at least two different, maybe more than two, but at least two different monomer unit combining together. That is copolymerization. This is butadiene and this is styrene. So SBR, styrene, butadiene, and rubber. Acha, do in your real life, where you are using styrene, butadiene, and rubber? Tell me. These things are actually more important. You have to be just into your real life situation. Different type of polymer people are using. You should know that what polymer you are using. That will give him interest. So what can you tell me where you are using SBR? Still now you are using, but in the school level you used more. Yes, yes, that was the clue. School level you used more. Now you are using little, only making the graph, right? So that is SBR. Acha, that one experiment. If you keep this SBR, just recently brought SBR, which is quite soft and good one. If you keep in the refrigerator, deep freeze, after 2 hours, if you take it out and you can hammer it, it will break it into pieces. Why it is so? Why does it happen? Crystallization happen. Crystallization happen, and crystals are hard but brittle. Crystals are hard and brittle, and amorphous material is flexible, elastic. So this SBR is elastic in nature, but if you keep it in the deep freeze, it becomes hard and crystalline. So whenever below certain temperature this phenomena happens, that is called glass transition temperature. It is acting like a glass because glass breaks. Glass হাত থেকে পড়ে গিয়ে ভেঙে যেত. So glass breaks. If you hammer the glass, it will break. So it is called glass transition temperature. Below that temperature, it will become glass-like material, and above the temperature, it will become flexible. This is called TG, capital T, small g, subscript G, TG, glass transition temperature. Okay? I can give question. What is glass transition temperature? Below which the polymer behaves like a glass. Above this temperature, polymer behaves like a elastic one. Elastic polymer. Polymer will have some elasticity property. Achha, there are two common property. One is, not two, there are so many. Common property. One is called glass-like property. It breaks. If it falls, it breaks. It cracks. That is called glass-like property. There is another type of property which is called quite good flexibility. If you pull, it will be elongated. If you release, it will come back. Elastic. That is one. Plasticity. If you fold it, it will be folded, but not break. And it will not come back also. That is called plasticity. Understand the difference. Elastic you pull, release, it comes back. Plastic you pull, release, it will be elongated, it will not come back. That is called plasticity. Elasticity and plasticity. Plastic-like property, that is plasticity. Elastic-like property, elasticity. And there is another one, glass-like property. Okay. So same polymer having different type of properties. Every polymer has got some plasticity, some elasticity, some glass-like property. Okay, because they are amorphous, so they are a combination of all those properties. Same thing is, it is there. All those properties are there.
So when will exhibit the
Plasticity property. No, every material has got certain plasticity. Some material will have more plasticity, less elasticity. Some material will have more elasticity, less plasticity. But every material has got some plasticity, some elasticity. I'll give you one example. Girder, you are using girder. If you pull up to certain extent, it will not be torn. It will be elongated. Achha, keep in that elongated form over a long time, what happens? It becomes elongated. That is its plasticity property. And whenever you release, immediately it comes back. That is its elasticity property. But keep it in that state over a long period of time, and then you release, then you will find it will become elongated. It is plasticity property. Same material has got plasticity property, elasticity property. Achha, which one is more elastic? steel or gutter? Steel. Why? Same amount of force you are giving, you are getting less elongation. So these are the examples where you are using acrylic lenses. Acrylic lenses as an example. Contact lens, polymethyl methacrylate, PMMA. That is hard glass lens. FEMA, polyhexaethyl methacrylate. Polyhexaethyl methacrylate, that is called FEMA. That is a soft contact lens. So many we are using contact lenses, no? So you should know about where we are using. So this contact lens is acrylic polymer. Ajay, have you seen some container, the case, plastic glass-like material, but we call it fiber. Wrong way we are calling it fiber. It's not fiber. What do you know? You know what is that? Have you seen that transparent cover or container? That is, we are having some digital balance, and that there is a cover, case cover. That case cover is transparent, looking like glass, but it will not break so easily. What is the material?
So it is PET, polyethylene.
It is actually PMMA, polymethyl methacrylate, acrylic polymer. Acrylic polymer. Now, always I cannot say specifically, it is acrylic polymer. Now, different company may use different type of polymer. That sort of variation will be there. But these are acrylic polymers. Achha, have you seen sometimes you are giving a coating onto nameplate, that a glossy type of coating, and it's a polymery coating. It's a very good transparent looking, like araldite gum. Araldite gum, if you put somewhere on the surface and after it is dried up, you get a very good thin film coating, isn't it? So this type of acrylic emulsions, these are called all acrylic emulsions.
That is epoxy resin.
Epoxy resin, acrylic emulsion, both are exist. Epoxy resin is also there. This araldite is epoxy resin. Achha, nylon is bearing bag, nylon rope, thread. Nylon you are giving reinforcing into a tire reinforcing you are doing by nylon wires. So if you tear the tire, you will find nylon thread inside. Achha, but what are the main material of a tire? That is natural rubber. But it is giving reinforcing made by some metal you wear as well as nylon rope. Coming to methods of polymerization. Okay, so here initiation, propagation, termination, that is the mechanism, the Ziegler-Natta catalyst, as I told you. So this mechanism is here. This is the catalyst. This is the monomer unit. So, and we are getting a polymer. Now, but this polymer is not a polymer. This is the mechanism. It is shown how the initiation is there. So here. This is the only catalyst is combined, getting joined. Catalyst has got joined here. Okay, and what is your radical formation is taking place. Yes, here is the total mechanism shown. So you are getting total polymer. So living polymer means it is still doing the reaction. It is not yet dead. Dead means ended, and living means it is still going on. Active. Living means active in this case. So this is the propagation, first initiation followed by propagation and finally termination. Termination happens and this is called dead polymer. Dead polymer is ended. Dead is ended in this case. Now emulsion polymerization, this is the actual method of polymerization, how it is done. These details are there. Actually if you want to do it, how do you do it? This is the method. You may not remember the whole thing, not record also. But generally just for a rough idea you should know that it is happening in the emulsion phase. It is happening in the emulsion phase. Emulsion is a phase. Suspended monomer into some solvent. Small globules are floating. That is emulsion. So here this droplets are merging together and polymerization is going on. Polystyrene is obtained by this method. And this is the initiator, K2S2O8. So the whole thing is written here. What is the purpose of this sodium lauryl sulfate? Emulsifier. That means it allows to float on the surface, the whole thing. Otherwise, all the monomers will be specified at the bottom, and then the reaction will not take place. That's why
Something like
it should emulsifier means all the globules are getting stabilized. Globules are getting stabilized. Otherwise, globule has a tendency to merge together. So that emulsifier is allows them to stay in that state without getting accumulated. That is emulsifier. Purpose of emulsifier. Initiator producing the initiation, doing the initiation, and then propagation going on. So PVC, PVA, polyvinyl chloride, polyvinyl alcohol, this type of polymers are made this emulsion state. Advantage, rate of polymerization is high. I think I told you already. A very high molecular polymer is obtained. Easy heat control. Lot of heat not required. Controlled heat. So that means your fuel cost is also low. Low fuel cost. If you have to heat a lot, then fuel cost will be very high. Actually, too much of heating not advisable also, because organic molecules, they will be burned. Delicate, break, they will burn, charred. This problem will be there. So heating will be always controlled up to a few hundred degrees, 100, 200, not more than that. So disadvantages: difficult to remove entrapped coagulant emulsifier. Could you understand? This emulsifier coagulant, what we are adding for our purpose, for our benefit, so that will be there in the globular form inside the polymer. That is difficult to take out. Sometimes it can be going out, but sometimes it may not be. And in that case, the polymer quality will go down. Quality will go down because the emulsifier is entrapped inside. The polymer needs additional cleanup and purification, economically costly, because why? Everything you have to buy or whatever you are adding, nothing is free here. So it is becoming costly. Suspension polymerization. One was emulsification. That is a method of addition. Then another method is called suspension. In the suspension state it happens. Emulsion state and suspension state. What is the difference? Suspension means only on the surface, and emulsion means throughout the bulk. Got the idea? Emulsion means in the globular form throughout the bulk, and suspension means suspended on the surface. So reaction whatever happening on the surface. PVC and PMMA are formed by this suspension mechanism, suspension method. Mechanism is addition. If you say mechanism, all of them are undergoing addition, but it is in the state of suspension. PMMA and PVC suspension, but PVA was emulsion. These polymers are usually hard polymers, and this one more thing. These polymers are insoluble into any solvent, like polythene as example. There is no solvent available that can dissolve polythene. Okay, that is advantageous sometimes. You can use polymer container for carrying solvents, organic solvents. Otherwise, if it melts and dissolves, then it is gone in the way. Okay, sometimes it is required. Always should not be reactive. Sometimes inert also. So these polymers are not dissolved into any solvent, organic solvent. Which polymer? Addition polymers. Physical property. These polymers are having crystallinity. Polythene. If you have a high density polyethylene, you find more crystallinity. Ultra high density polyethylene, you get high crystallinity. Crystals are formed into the polymer itself. Polymer is amorphous, but into the amorphous material there can be small microcrystals. That is called crystallinity. You don't expect that polymer will give a huge crystal. Small microcrystals inside the amorphous material. That is called microcrystals. Okay, that is crystallinity. Ajay, have you seen any crystallinity into glass? You have seen? Where? No, crystallinity I have not seen. Air bubble is something different. Air bubble you can visibly clear, you can understand this is air bubble. But have you seen crystals or not? Sometimes in the glass you will find something is lustrous is there. From inside the glass material, window pane, or in the bus, when you are traveling by bus, look at the glass panel, and you'll find some things are just glittering inside. Glittering inside the glass, that is crystal. When sunlight is coming in, it is getting scattered. That's why you can see the crystal. Got it? So that means it is visible. We have seen it. May not always realize it. But this is a crystals inside the glass. That happened. Why does it happen? Because of long exposure with heat and cold. The glass is getting exposed to heat and cold alternately. Daytime heating and nighttime cooling. Bus is going in the day night always. So heating and cooling is going on. And the glass is becoming hazy. Why it is becoming hazy? Crystallinity. Crystallinity. Because of crystallinity becoming hazy. And when you make the new glass, it is purely amorphous. Purely glass only. It has no crystal. That's why it is transparent. And when it is becoming crystalline partly, it will become hazy. That you can find always. You have a old glass, কাঁচের glass দেখেছো? Old glass. So it becomes semi-transparent or translucent, right? But new one is quite transparent. But when it is becoming older, it becomes semi-transparent. Why does it happen? Crystallinity. You have seen it, but you could not realize it. That is crystallinity. Okay. So it is happening like this. In the amorphous, there are crystals like this. There are crystals. Unoriented crystallized, oriented crystallized. If you make it oriented crystallized, it will become quartz. Quartz glass. Much harder. If you drop, it will not break. By chance, if you drop, at least a few impact, it can tolerate. It will not break. That is oriented crystals. And unoriented crystals will break because they have not proper orientation, so they will not give much of stability. Strength, they are not giving strength. But oriented crystals are having more strength. Amorphous state. What is amorphous state? Random. There is no orientation at all. Initially, when you make the glass, it's like that only. Slowly, the orientation takes place, and you are getting partly crystalline character. And the more the crystallinity, more it will be harder, and it will break and crack. Sometimes it can crack itself. Okay? Have you ever seen that if it is too hot, the glass is broken? Or it happened to me only also. So there is a mirror, and in the some summer season I was nearby here, living somewhere around here. So there is too much of heat in that room. That is a top floor room, extreme heat, and suddenly found there is a totally become divided into two parts. The mirror is broken into two without any hammering, nothing. Without any knocking, hammering, nothing happened. Automatically there is a huge cut. That happened because of crystallinity. Because crystallinity appeared inside, and that is creating a lot of stress. Crystal here, amorphous here, uneven, na? It's creating a lot of stress, and by the stress is broken, and it happens. So this is some example that polymerization, as I told, the molecular, etc. So let's have some example. This is 100 number, 500 number, 50 number. Okay. So molecular 2800, 14000 and 1400. So what will be the average? By 3. This is number average. Okay. Mass into number by total number. Mechanical strength. Strain and stress. Okay, this much of detail I don't want to push into your head. It will create trouble. Structure of PVC. Structure of polystyrene. Plastic deformation. Plastic deformation I told you already. Elastic behavior, character, I told you. Okay. Before showing you itself, I told you everything.